The wind blows cold across the frozen steppe, carrying whispers of a world that once was. Once upon a time, thousands upon thousands of mammoths roamed these lands. Now, only a small herd remains, their massive bodies moving slowly through the wet, heavy snow. The ice is retreating. Winter is no longer what it used to be. And without realizing it, these magnificent animals are walking toward their end. This is the story of how the mammoths disappeared from our world. Not in a single catastrophic day, not with one dramatic extinction event, but through a series of small changes, environmental shifts, human choices, and evolutionary mistakes that ultimately extinguished forever one of the most incredible creatures Earth has ever seen. To truly understand their end, we must first journey back to the beginning. Who were the mammoths, really? What was their world like? And what can their disappearance teach us about the fragile balance of life on our planet? The giants among us for us today, mammoths exist almost as legend. We imagine enormous, hairy elephants with giant, dramatically curved tusks, lost in an endless landscape of snow and ice. They feel mythical, like dragons or unicorns, creatures from another time entirely. But for thousands of years, for our primitive ancestors, mammoths were not legends at all. They were everyday reality. They were as real as the deer in the forest or the fish in the river. They were part of the natural world, part of survival, part of life itself. Mammoths were close evolutionary relatives of modern elephants, sharing a common ancestor millions of years ago. Some species were significantly larger than today's elephants, others were smaller, and some even became dwarfed versions on isolated islands. The most famous and iconic is the woolly mammoth, the species that survived longest and adapted most successfully to the Ice Age conditions. Picture them, you might, standing up to 3 meters tall at the shoulders, roughly the height of a 2-story building. Their entire bodies were covered in thick, shaggy brown fur that hung down in heavy curtains, sometimes reaching nearly to the ground. This wasn't just for show. Underneath that impressive coat of fur, a thick layer of insulating fat protected them from temperatures that could plunge far below freezing. Their ears were notably small compared to modern elephants, an evolutionary adaptation to prevent heat loss and protect against frostbite in the brutal cold. Their most striking feature, of course, were their tusks. These magnificent ivory structures were long and dramatically curved, sometimes exceeding 4 meters in length, sweeping outward and upward in graceful arcs. These tusks weren't just for display. Mammoths used them to sweep away snow, to reach the grass beneath, to strip bark from trees, to defend themselves from predators, and during mating competitions between males. Mammoths were highly social animals. They moved in matriarchal herds, led by experienced older females who knew the migration routes, the location of water sources, and how to navigate the challenges of their harsh environment. Mothers traveled with their calves, young females learning the ways of survival, and young males who would eventually leave to form bachelor groups or live more solitary lives. They followed the seasons and the pastures, constantly searching for food. Their diet consisted primarily of dry grasses, but they supplemented this with moss, small shrubs, roots, and whatever vegetation they could find in their challenging environment. An adult mammoth needed to consume enormous quantities of food each day, sometimes over 200 kilograms, just to maintain their massive bodies. They lived in what seems to us an impossibly harsh world, but it was one they knew intimately. A world of endless snow, biting winds that could strip the warmth from your body in minutes, vast frozen plains that stretched to the horizon, and skies so clear and cold that the stars seemed close enough to touch. Around them roamed other magnificent Ice Age megafauna. Woolly rhinoceroses with their thick fur and massive horns, enormous steppe bison, larger than any bison alive today, saber-toothed cats with their distinctive elongated canine teeth, apex predators capable of taking down the largest prey, massive cave bears that hibernated in deep caverns throughout the winter. The last great ice age was truly a time of giants, a cold earth teeming with spectacular wildlife that would seem almost impossible to us today. The bond between humans and mammoths, for early humans surviving in these extreme conditions, mammoths represented something profound. They were everything. They were food, shelter, tools, and raw materials, all in one magnificent package. A successfully killed mammoth meant survival. It meant meat for weeks. enough to feed an entire tribe through the harshest part of winter. For our ancestors, that meat wasn't a luxury or a special treat. It was literally the difference between life and death, between watching your children starve and seeing them survive another season. They roasted the meat over carefully tended fires, smoked it to preserve it, dried it, and employed every preservation technique they could discover to make it last as long as possible. Every scrap was precious, nothing could be wasted. But the value of a mammoth extended far beyond just meat. The sinew became incredibly strong cordage for binding tools and weapons. The thick hides became tent coverings that could withstand fierce Arctic winds. The bones became the structural framework for shelters in regions where trees were scarce or non-existent. Archaeological evidence has revealed truly remarkable structures. In some areas of Eastern Europe, researchers have discovered actual houses constructed almost entirely from mammoth bones and covered in mammoth skins. These weren't crude shelters. They were sophisticated dwellings, circular or oval in shape, with bones carefully selected and positioned to create stable, weatherproof homes. Imagine building your entire house from the skeleton of these magnificent creatures. The relationship between humans and mammoths extended beyond mere utilitarian use. Throughout caves across Europe and Asia, we find engravings, drawings, and paintings depicting mammoths. These artistic representations suggest that humans didn't just hunt mammoths, they observed them, studied their behavior, tried to understand them, and incorporated them into their cultural and possibly spiritual lives. These cave paintings show remarkable detail and accuracy. We can see the distinctive shape of their tusks, the texture of their fur, even behavioral scenes showing mammoths interacting with each other. This means that for the people of that time, mammoths occupied a significant place in their consciousness. They were as fundamentally woven into the fabric of human existence as horses or cattle are for us today. Yet despite their size, their strength, and their seemingly perfect adaptation to their environment, even these giants would eventually fall. The world built on ice. The entire world of the mammoth was fundamentally built on ice. As long as the great ice sheets held firm, their ecosystem remained stable. But nothing in nature remains static forever. During the last ice age, which reached its peak approximately 20,000 years ago, enormous ice sheets covered vast portions of the planet's northern hemisphere. Ice more than a kilometer thick stretched across what is now Canada, northern Europe, and much of northern Asia. So much water was locked up in these massive glaciers that global sea levels were dramatically lower than they are today, sometimes more than 100 meters lower. This created land where today we see only ocean. The Bering Strait between Alaska and Russia was dry land, forming a massive land bridge that connected Asia and North America. The British Isles were connected to continental Europe. Indonesia was largely one continuous landmass. Mammoths could walk across regions that are now underwater. This Ice Age world was characterized by vast expanses of what scientists call mammoth steppe or tundra steppe. These were cold, dry grasslands, very different from the Arctic tundra we see today. The mammoth steppe was more productive, supporting dense populations of large herbivores. It stretched in an almost unbroken corridor from Spain across all of northern Eurasia and into North America. But the Earth's climate has never been static. It changes constantly, driven by complex interactions between solar radiation, atmospheric composition, ocean currents, and orbital variations. About 12,000 years ago, the last ice age began to end. This wasn't a sudden switch. It was a gradual process. But from a geological perspective, it happened relatively quickly. Temperatures began to rise slowly but steadily, century after century. The massive glaciers that had seemed permanent began their long retreat. Sea levels gradually rose as millions of cubic kilometers of ice melted and flowed back into the oceans. The great frozen steppes that had been mammoth habitat began to transform fundamentally. The dry, hardy grasses that mammoths had specialized in eating began to shrink in range and abundance. In their place came forests expanding northward as temperatures allowed. Wetlands and swamps appeared where once there had been frozen ground. New plant species colonized the changing landscape, but these weren't necessarily plants that mammoths had evolved to efficiently digest. For many animal species, this environmental transformation wasn't necessarily catastrophic. Life has always been about adaptation. Some species adapted to the new conditions, Others migrated, following their preferred habitats northward or to higher elevations. Some even thrived in the new, warmer world. But mammoths were specialists. They had spent hundreds of thousands of years evolving to become perfectly adapted to extreme cold. Their thick fur, their insulating fat layer, their small ears, their specialized digestive system capable of extracting nutrition from tough, fibrous grasses, all of these features were optimizations for a world of eternal winter. They were magnificent examples of evolutionary adaptation to a specific niche. But evolution is a double-edged sword. Extreme specialization makes a species incredibly successful in its specific environment, but it also makes them vulnerable when that environment changes. Mammoths were not well equipped for a world that was becoming progressively warmer, wetter, and greener. The slow collapse. Imagine a herd of mammoths living through this time of transition. The changes would have been subtle at first, barely noticeable within a single mammoth's lifetime, but across generations, the cumulative effects would have been devastating. The young mammoths struggle to find sufficient food because the preferred grasses are less abundant than in their parents' time. The traditional migration routes that herds had followed for countless generations no longer lead to the best grazing areas. Where once there were open, frozen plains easy to traverse, now there are swollen rivers that are difficult to cross, extensive lakes that block traditional paths, and areas of deep, sticky mud that can trap even an adult mammoth. The overall habitat suitable for mammoth was shrinking. Populations became increasingly fragmented, separated by growing forests or expanding wetlands. This meant that mammoth herds that had once been part of a larger interconnected population became isolated from each other. Gene flow between populations decreased, which has long-term evolutionary consequences. The changing climate didn't just mean less suitable food and fragmented habitat. It also brought new biological challenges. Parasites and pathogens that had previously been limited by extreme cold began to spread into regions that were now warm enough to support them. Longer, milder summers meant that disease-carrying insects could complete their life cycles and multiply in greater numbers. Less harsh winters meant that parasites could survive year-round rather than being killed off by extreme cold. For mammoth populations already stressed by habitat loss and food scarcity, increased disease pressure could be the factor that tipped them from struggling to declining to disappearing. For an individual mammoth living through these changes, one year might seem similar to the previous one. The changes were gradual enough that they might not be immediately obvious. But if we could watch the mammoth population across centuries, we would see a clear and disturbing trend. Herds gradually becoming smaller. Some populations in marginal areas simply vanishing without survivors. The total range of mammoths slowly contracting. The human factor, but environmental change wasn't the only pressure mammoths faced. There was another factor in the equation, one that would prove increasingly significant. Humans. When the climate began its dramatic transformation at the end of the Ice Age, humans were also changing and changing rapidly. Homo sapiens was becoming more technologically sophisticated, more organized, and more effective as hunters. Weapon technology improved significantly. Stone spear points became more carefully crafted with shapes optimized for penetration and lethality. The atlatl, or spear thrower, gave hunters the ability to launch projectiles with much greater force and from a safer distance. Eventually, the bow and arrow would provide even more advantages. But technology alone wasn't the whole story. Humans were becoming better at cooperative hunting strategies. Hunting parties became more organized and coordinated. Hunters developed sophisticated knowledge of animal behavior, learning to predict mammoth movements and exploit their instinctive responses. Hunters learned to use terrain to their advantage. A precipice could turn a mammoth's panicked retreat into a fatal fall. A frozen lake with thin ice could become a deadly trap. A swamp or bog could immobilize even the strongest mammoth, making it vulnerable to spears and arrows. An adult mammoth was an incredibly dangerous opponent in direct confrontation. A single charge from several tons of angry mammoth was enough to kill multiple hunters. Mammoth tusks could gore and throw a human with devastating effect. Direct confrontation was rarely the preferred strategy. But if hunters could create panic in a herd, if they could stampede mammoths in a particular direction, the animal's own size and momentum could become their greatest liability. Mammoths might run blindly off cliffs, into lakes, or into marshes where they would become stuck and helpless. We don't have definitive evidence that humans alone, through hunting pressure in just a few generations, were capable of completely exterminating all mammoth populations. The archaeological record doesn't support that simplistic narrative, but we do have evidence of a troubling pattern. Wherever modern humans spread into new territories, large animal species often began to disappear relatively soon after human arrival. This pattern has been documented on multiple continents. In Australia, North America, South America, and various island ecosystems, the arrival of humans correlates strongly with the extinction of megafauna. This is not just coincidence. While humans alone might not have been capable of driving mammoths to extinction, humans combined with climate change created a devastating combination of pressures. Fewer suitable habitats meant mammoth populations were already stressed. Less available food meant herds were smaller and individuals potentially weaker. Add increased hunting pressure on top of these existing stresses, and you have a recipe for population collapse. Every mammoth herd that disappeared was a fragment of the species, future vanishing. Every isolated population that was hunted out or died from natural causes without reproducing was a reduction in the overall genetic diversity and resilience of the species. The final refuge is when a species begins its decline toward extinction. It rarely disappears uniformly everywhere at once. Typically, small populations persist in favorable refuge habitats, sometimes for surprisingly long periods after the species has vanished from most of its former range. For mammoths, some of these final refuges were on remote, cold islands in the Arctic. The most famous of these is Wrangel Island, a remote island in the Arctic Ocean north of eastern Siberia. On Wrangel Island, mammoth populations survived for thousands of years after mammoths had disappeared from the continental land masses. While the last mammoths on the mainland died out approximately 10,000 years ago, mammoths on Wrangel Island persisted until approximately 4,000 years ago. This means that mammoths were still alive when the ancient Egyptians were building pyramids. These island mammoths were interesting in their own right. Over generations of isolation on a limited landmass with finite resources, they underwent what scientists call insular dwarfism. They became smaller than their continental ancestors, an evolutionary adaptation to limited food resources. These dwarf mammoths stood only about 2 meters tall at the shoulder, significantly smaller than mainland woolly mammoths. But survival in small, isolated populations comes with significant biological costs. Population genetics teaches us that small populations face serious challenges. With fewer individuals, there is less genetic diversity. This means that harmful genetic mutations are more likely to become widespread in the population. Inbreeding becomes unavoidable, potentially leading to reduced fertility, increased susceptibility to disease, and accumulation of deleterious traits. Small populations are also more vulnerable to random catastrophic events. A single particularly harsh winter, one severe disease outbreak, one storm that destroys critical food resources, or even the arrival of a small group of human hunters could potentially wipe out an entire island population. Eventually, even these last silent islands were emptied of mammoths. The final mammoth on Wrangel Island died approximately 4,000 years ago. The last mammoth on the entire planet died without any awareness that it was the last. For that individual animal, it was just another day, another search for food, another attempt to survive in a challenging environment. But for Earth's natural history, it was the closing of a chapter that had lasted for millions of years. An entire genus of remarkable animals had vanished forever. Frozen in time, yet mammoths have not disappeared entirely from the Earth, at least not physically. The permafrost of the Arctic has acted as a natural time capsule, preserving their remains in remarkable condition. In Siberia, Alaska, and other regions with permanently frozen ground, scientists and local people have discovered mammoth remains that are almost unbelievably well preserved. Not just fossilized bones, but actual soft tissue, whole bodies, sometimes complete with skin, fur, internal organs, stomach contents, and even recognizable eyes. Some of these discoveries were made by children playing outside, stumbling across a massive tusk protruding from a riverbank. Others were found by ivory hunters searching for mammoth tusks to sell. Some were revealed when permafrost thawed, or when erosion exposed ancient remains. The level of preservation can be extraordinary. Scientists have found mammoth stomachs still containing the partially digested remains of their last meal, allowing researchers to identify exactly what plants they were eating. They found intact fur that still retains its original color and texture thousands of years after the animal's death. They've extracted muscle tissue, organs, and even blood from some specimens. For researchers, these frozen remains are invaluable scientific treasures. They provide information that fossils alone could never give us. From analyzing stomach contents, scientists can reconstruct in detail what mammoths ate and how their diet might have changed with environmental conditions. From studying growth rings in their tusks, similar to tree rings, researchers can understand their age, growth rate, and even seasonal variations in their environment. Most remarkably, scientists can extract DNA from these frozen tissues. This has allowed researchers to sequence the entire mammoth genome, compare it with modern elephants, reconstruct their evolutionary history, and understand the genetic changes that occurred in populations as they became isolated. Every frozen mammoth discovered represents a connection to the past, a tangible piece evidence of a vanished world. It's not just an abstract fossil in a textbook. It's a real individual animal that once walked the earth, that felt cold and hunger, that possibly cared for offspring, that experienced fear and pain. Could they return? This brings us to one of the most fascinating and controversial aspects of the mammoth story, the possibility of de-extinction. Today's biotechnology has given us the ability to read and potentially manipulate genetic information with unprecedented precision. Scientists have sequenced the complete mammoth genome from well-preserved specimens. They understand the genetic differences between mammoths and their closest living relatives, Asian elephants. Some researchers are exploring whether it might be possible to use genetic engineering to create elephants with mammoth characteristics. This wouldn't be a true mammoth exactly. It would be a genetically modified Asian elephant incorporating certain mammoth genes for things like thick fur, cold-adapted hemoglobin, and increased subcutaneous fat. The idea is extremely controversial and raises profound ethical questions. Supporters argue that such a project could help us better understand mammoth biology and ecology. Some even suggest that introducing large herbivores into Arctic ecosystems might help restore and maintain grassland habitats, potentially helping to combat permafrost thaw and climate change. Critics raise numerous concerns. Would we be creating an animal only to keep it in captivity, never able to live naturally? Do we have the right to manipulate life in this way? Would we be creating something that could suffer? An animal without a true home or ecological role? And, perhaps most significantly, wouldn't the resources spent on such a project be better used protecting the endangered species we still have? But regardless of whether mammoth de-extinction is advisable or even possible, the very fact that we're having these conversations speaks to something profound. For thousands of years, humans drew mammoths on cave walls, trying to capture their essence in ochre and charcoal. Today, we attempt to reconstruct them in computer simulations and DNA sequences. This demonstrates the immense power modern humans have over the natural world. We have the technological capability to potentially bring back extinct species, to fundamentally alter ecosystems, to reshape life itself. With such power comes enormous responsibility. Lessons for today: the story of mammoths is not just ancient history or paleontological curiosity. It speaks directly to our present moment and our future. Mammoths didn't disappear due to a single cause. They vanished because of a complex combination of factors that created a perfect storm of extinction pressures. Climate changed dramatically, reducing and fragmenting their habitat. Their food sources diminished. Hunting pressure increased just as populations were already stressed. Herds became smaller and more isolated, reducing genetic diversity and resilience. Eventually, the populations became too small to recover, and they spiraled into extinction. This same combination of factors threatens numerous species today. Rhinos, elephants, tigers, polar bears, countless other animals that seem normal and permanent to us now, just as mammoths seemed permanent to our distant ancestors. But unlike our ancestors, we have the knowledge to understand what's happening. We can see the patterns. We understand the science of extinction. We have the capability to make different choices.